So this is from the solving equations homework. Question 2a. We start off with x squared plus x minus 6. So a reminder, because we're doing factoring here, we're trying to find, and we have nothing in front of our x squared, we're trying to find our factors of negative 6 that add to make 1. So if we remind ourselves what multiplies to make negative 6. Well, 1 times 6 makes 6, and 2 times 3 makes 6. But that's all. There's nothing else. And it needs to be negative, which means one of these needs to be positive, and one of these needs to be negative. We're trying to get to a positive 1, so that tells us that we want a negative 2 and a positive 3. So then this factors into x minus 2, x plus 3 equals 0. Then once we've figured that out, that means either x minus 2 equals 0 or x plus 3 equals 0. So we go ahead and we set those up. Sorry, don't hit the brackets on this. X minus 2 equals 0 or x plus 3 equals 0, which gives us our answers of x equals 2 or x equals negative 3. So from there, we'll go on to the next one. But that's essentially what we're going to be doing for all of these problems. We factor it, then we take the solution. So without even erasing, I can go on to the next one. We can do x squared minus 25 equals 0. Now, we don't have our customary 3 terms, the ones that make us recognize that we're doing a factoring question. We just have the 2 terms, but the 2 terms are both perfect squares, which tells us this is a difference of squares. And the difference of squares, of course, is a very specific way that it factors. It's the square roots of both terms separated by different signs. And it's still equal to 0. And because of that, we can then say that either x plus 5 equals 0 or x minus 5 equals 0, which means x equals negative 5 or x equals positive 5. Go ahead and jump in if you have questions at any point. Otherwise, I will just keep moving through the questions. Moving on to C, which is saying, hold on just a second. Which is saying 6x squared minus 4x equals 2. So this is one we're going to have to rearrange. Zara, are you looking to write a test today? Okay, so it gives it to us like this. We're going to need to rearrange it so that it's in the form we were looking for. And all we really need to do is take this 2 over to the other side of the equal sign. So when we rewrite this, this becomes 6x squared minus 4x minus 2 equals 0. Now we do our AC factoring. We multiply our 6 times our negative 2, and that gives us negative 12. Then we're looking for our factors of negative 12 that'll get us to negative 4. We remind ourselves what our pairs of factors are: 1 and 12, 2 and 6, 3 and 4. This gives us a low of 11 and a high of 13. This is a low of 4 and a high of 8. And this is a low of 1 and a high of 7. Well, there's the 4 that we're looking for. We want it to be a negative 4, so it's going to be a negative 6 and a positive 2. So I can then say 6x squared minus 6x plus 2x minus 2 equals 0. Yes, you can take that test on Thursday. No problem. Now that we've done the separation, we will do this by grouping. So I can take a 6x out of the first two terms. And when I do that, I'm left with x minus 1. And then I can pull a 2 out of the second two terms. And that's also going to leave me with an x minus 1. X minus 1 becomes my common factor. My other two terms are what's left. And from there, we can set these up equal to 0. Which tells us that x will equal 1, or x will equal negative 1/3. Now I just jumped there, but I brought the 2 over and divided by 6 on both sides, then reduced it. So I just did that in one quick step. Just while I'm paused, James, you came in a little bit late. Were you looking to write a test today, or are you just here to see worked problems? You can, no problem. Just wanted to make sure that I wasn't missing a request. Okay, so carrying on then, we will move on to 2D. Very, very similar to this question we've just done. So, question 2D is saying 5a squared equals negative 33a plus 14. Yes, Sarah, you can absolutely take test 4 on Thursday. You weren't, and so my recollection is then that you're actually up to date. You don't need to take test 3 today, right? No, you've taken it, so you should be okay. Okay, good. Okay, so this is how the question is given to us. We want everything on the same side, though, so I'm going to move this 5a squared to the other side of the equal sign. And it's going to look like that as soon as I do that. And we're not used to the 0 being on the left-hand side, so it's not a big deal just to put it on the right-hand side. It means the same thing. So we're good. So this is now what we're going to try and factor. It is numbers at front and back, so we have to do the AC factoring thing. Our little sidebar says we want negative 5 times 14, which is going to give us negative 70. A reminder of our pairs of numbers that make negative 70. So we're trying to get to negative 33 here. And I don't have to go any farther. That's the one that's going to do it, 2 and 35. We want a positive 2 and a negative 35. So now we can rewrite this. As negative 5a squared minus 35a plus 2a plus 14 equals 0. By grouping, out of the first two terms, I can pull out a negative 5a, which leaves me with a plus 7. Out of the second two terms, I can pull out a 2, which also leaves me with an a plus 7. A plus 7 is then common. My other two terms go in the second bracket. And then we solve for a. So a plus 7 is equal to 0, or negative 5a plus 2 equals 0. Isolating our variable says a is equal to negative 7, or a is equal to 2 over 5.
Sorry, Morgan, why is that 2 over 5, not minus 2 over 5?
Okay, so I'll take it in pieces.
Sorry.
No, it's a very good question. The 2 comes over, and we're left with negative 5a on this side, but when the 2 goes over, it also becomes a negative 2. So that when we divide by negative 5 on both sides, the negatives then cancel. Because I have a negative on top and a negative on the bottom. And so in the end, it ends up positive.
I see, thanks, yes.
Okay. Any other questions on this one before I go on?
No, that was okay.
Okay. We'll move on to E. Much faster, much simpler question. Uh, 2E says x squared minus 4 equals 0. So this is a nice difference of squares. Square in the front, square in the back, separated by a minus sign. So this factors into x plus 2 and x minus 2 equals 0. So then our answers are for x plus 2 equals 0, or x minus 2 equals 0, which means x is equal to negative 2, or x is equal to positive 2.
That's good. I think I've got those ones now. It's all right. Thanks, Morgan. Maybe
Great.
someone else have something.
Sorry, so with the, you mean the difference of squares or the factoring in general?
And I think the factoring in general. I think I can do the other ones on my own.
Okay, perfect. I will leave you to go through those then. Any other questions I can answer while I'm here? And that goes out to you too, James, if you've got any questions you'd like me to go over.
Could you do the inequalities as well?
Sure.
Well, nobody's got anything else.
Solve the following inequalities.
Yeah, number 4.
Okay, so this is going to be very much like what we've done. We're just going to add a step to it. So I'll do 4A and B, and you should probably understand what's happening by the end of those two examples. Okay, 4A says x squared plus x less than or equal to 6. So what we want to do is we want to get everything onto one side of the equal sign so it looks like something we're used to seeing. So this ends up doing this. We have x squared plus x minus 6 less than or equal to 0. Now I can factor this side. Multiplies to make 6, adds to make 1 with a negative there. This becomes x plus 3, x minus 2, less than or equal to 0. We do exactly what we would do previously. We want to find a couple of spots here. So we can solve this as x plus 3 equal to 0, or x minus 2 equal to 0. Because of that, we know that we're looking at x equals negative 3 or x equals positive 2. Now, because this is an inequality, we want to start to think of these things as regions as opposed to just the shape of the line, because we're trying to figure out which side of the line we actually want, which side actually gives us the part that satisfies the inequality. So if we think of this as a number line just really quickly, make sure that I have this all in the screen here. There's our 0. There's negative 3. There's positive 2. So we have 3 places that we need to check. We need to check this side, everything that's less than negative 3. We need to check that side, everything that's greater than positive 2. And we need to check this middle section, everything between negative 3 and positive 2. So in order to do that, I'm going to choose 3 numbers that I want to test. I'm going to try negative 4. I'm going to try positive 3. And I'm going to try 0. Now, what do I mean by try? I'm going to put them into this equation right here and see what works out. So if I let x equal negative 4, do that in a different color just for emphasis, x is going to equal negative 4, then what I get is negative 4 squared plus negative 4 minus 6, and we want to know if that's less than or equal to 0. Negative 4 squared is going to be 16. Minus 4 minus 6. Negative minus 4 minus 6 is minus 10, so 16 minus 10 gives me a 6. Is 6 less than or equal to 0? No. So negative 4 does not satisfy. If we try x equals 0, this one goes really nice and quickly. We put 0 in for x. And I get 0 squared plus 0 minus 6 less than or equal to 0. Well, is negative 6 less than or equal to 0? Yes. So this is a yes. Because of that, I can make a pretty good guess on our last one what's going to happen. Sorry, I'm just going to squeeze it in here. 3 squared plus 3 minus 6 less than or equal to 0. Well, 3 squared is 9. 9 plus 3 is 12. 12 minus 6 is 6. Less than or equal to 0. And again, we say no. So we know that this is not the area that we want. So we know now that our answer has got to be between negative 3 and positive 2. So how do we end up writing our answer? Pretty much exactly like that. We're going to go from negative 3 to 2. So greater than, x will be greater than or equal to negative 3, but less than or equal to 2. And that's our answer. Yes, James, absolutely. I'm just going to do one more. I'm going to do 4B. I'm just going to give you guys a chance to make sure you have all of this. 4C. I can do 4C. I'll do 4C. It's pretty much exactly very, very similar to this question. Okay. For C, which says x squared less than or equal to 7x minus 12. I'm going to move everything over to the left-hand side just because that's the way I want the signs. So we end up with x squared minus 7x plus 12 will be less than or equal to 0. Then we factor it. What multiplies to make 12? Positive 12, but adds to make negative 7. Well, our answers there end up being x minus 3 and x minus 4. This means as soon as we set this up, I'm looking for x equal to 3 or x equal to 4 as the points that I'm looking for. Set up my number line really quickly. 0 is way down here. There's 3. There's 4. And I need to know less than 3, greater than 4, and between 3 and 4. So for less than 3, I'm going to go ahead and use 0. For greater than 4, I'm going to use 5. And for between 3 and 4, I'm going to use 3.5 as the obvious one. Having set that up, we're going to put these into the equation. I'll start off with 0, because it's the easy one. This tells us 0 squared minus 7 times 0 plus 12. Is that going to be less than or equal to 0? And the answer is no. 0, 0 leaves me with 12 less than or equal to 0, so no. We'll try 5. Gives me 5 squared minus 7 times 5 plus 12. This one's going to be close. 25 minus 35 plus 12 less than or equal to 0. 25 minus 35 is negative 10. Plus 12 gets us to 2. That is not less than 0, so that is also a no. Which means the area we're looking for, I don't even have to do the math, has to be the area right in the middle here. So again, we'll set up our answer. We're looking for x to be between 3 and 4. Any questions on that?
I think that's okay. Thank you.
Okay. Okay, let's keep going. We're going to go on to solving by substitution. Question 5 from the homework. Okay. Start off with question 5A. So this one is nice because it's partly set up for you right away. We have our two equations, y equals 5 minus 4x and 2x minus 3y equals 13. Because we are solving by substitution, we are, of course, looking to substitute one thing for another. So if we take a look at our equations, and we can see we already have one of them in this form, which helps us out. We know what y is equal to. Y is equal to this expression, 5 minus 4x. Because y is equal to that expression, we can replace y in the second equation with that expression. And it becomes the following. 2x minus 3 times 5 minus 4x equals 13. Now we go ahead and we solve for x. We can solve this equation because there's only one variable. So we go for it. 2x comes for the ride. Negative 3 times 5 is negative 15. Negative 3 times 4x is positive 12x equals 13. The negative 15 comes to the other side. My two x's come together, which leaves us with 14x equals 28. We divide by 14 on both sides, and it turns out that x is equal to 2. Now that we know what x is equal to, we can take this and put it back into our first equation to find out what y is equal to. So now y will be equal to 5 minus 4 times 2. 4 times 2 is, of course, 8. 5 minus 8 gets us negative 3. So now our solution becomes 2, negative 3. That is the point where these two lines will cross. Let's jump down and try F, just to pick a random letter to try out. F says 3x minus y equals 7 and 2x plus 2y equals 5. So we need to rearrange this to get some letter all by itself. We need to pick one of the equations and rearrange it so one of our variables is by itself. I'm going to pick the first equation, and I'm going to try and isolate y, just because it's already mostly on its own, so it shouldn't take too much. So this tells me then if I bring that 3x over to the other side, that I have negative y is equal to negative 3x plus 7. I don't want negative y, I want positive y, so I will divide by negative 1 everywhere. And when I do that, it tells me that y is equal to 3x minus 7. Good. That's the expression I will use for y then. And I will put that into my second equation. So 2x now plus 2 times 3x minus 7 equals 5. We continue to solve. 2 times 3x is 6x. 2 times negative 7 is negative 14. The negative 14 moves to the other side. My x's come together. And that tells me that 8x is equal to 19. This isn't going to be a pretty number, but it's going to work out. So we'll divide by 8 on both sides, and that tells me that x is equal to 19 over 8. This is now going to go back into this equation. And we see that y is going to be equal to 3 times 19 over 8 minus 7. I'm going to do two things at once. I know I'm going to have to subtract this 7, so I'm going to treat it as over 1. I will multiply it by 8, top and bottom. Which tells me I'll be doing minus 56 over 8. And I'll go 3 times 19. Sorry, which gets me 57 over 8. 57 minus 56. And it turns out that y will be equal to 1/8. So our final answer in this case becomes 19 over 8 and 1 over 8. Absolutely, James. I can do that one more time. I also have this recorded, so I can get this posted up tomorrow and you'll be able to see the recording. Okay, so that gets me to the end of 5. Oh, okay, we'll do that. So that's substitution in a nutshell. Even if the number doesn't look like it's going to be pretty, it goes in anyway. The answer comes out. Let's take a look at elimination. So we'll start off with 6a, and then I'll do one of the harder ones after that. So 6a gives us two equations. It gives us x plus 3y equals 7, and then negative x plus 4y equals 14. The thing that we're looking for when we do elimination is we're always looking to see how we can add or subtract our pair of equations so that one of our variables disappears, so that one of those variables goes to 0. So then, I look at this, I see I have a positive x in the first equation and I have a negative x in the second equation. So because of that, I decide that I can add these equations, and I will create a third equation, which should be much simpler. So x plus negative x gets me 0. 3y plus 4y gets me 7y. 7 plus 14 gets me 21. We'll divide by 7 on both sides, and it turns out that y is simply equal to 3. Well, that makes life very, very easy. I can now take this y equals 3. I can put it into either of the other two equations. I'm going to put it into the first equation just because that tends to be my habit. So x plus 3 times 3 is going to equal 7. 3 times 3 is 9. Subtract 9 from both sides, and we find out that x is equal to negative 2. So we take these two things, and it turns out our solution is negative 2, 3. Working through elimination isn't always quite that easy. We don't always have these equations set up nicely so that one of them disappears, but we can always make it so that one of them will disappear nicely. So let's take a look at an equation like that. Let's try 6D. So question 6D says 5x minus 9y equals 7, and 7y minus 3x equals negative 5. Now, the first thing we have to be careful about when we look at this question is to note that our variables are not presently lined up. So I'm going to rewrite this equation, and I'm going to flip the positions of x's and y's. My first equation remains the same. My second equation switches spots for a second. And now I can look at it and I go, okay, which variable do I want to make match? And a quick analysis says I probably want to make my x's match. It's much easier to find a spot where 3 and 5 are going to meet than it is finding where 7 and 9 are going to meet. 7 and 9 meet way up at 60 something, 63, and I don't want to deal with all of that. So instead, I'm going to make my x's match, and they match at 15, which means this first equation is going to multiply by 3, and this second equation is going to multiply by 5. And when I do that, I then have 15x minus 27y equals 21, and I have negative 15x plus 35y equals negative 25. Now I can add these equations. When I add these equations, the x's disappear. Negative 27 plus 35 gets me a positive 8y. Negative 21, positive 21 minus 25 gets me negative 4. Divide by 8 on both sides, reduce the fraction, and y is negative 1/2. I'm going to take that negative 1/2, I'm going to put it back into one of my original equations. I will just remind us up here that y is equal to negative 1/2. So then 5x minus 9 times negative 1/2 equals 7. Negative 1/2 times negative 9 is going to be positive 9 over 2. I'm going to move the 9 over 2 to the other side of the bracket, or to the other side of the equal sign, rather. At the same time, I will treat my 7 as over 1 and convert it so that we can do our subtraction. So then 5x will be equal to 14 over 2 minus 9 over 2, which is 5 over 2. We divide by 5 on both sides. Those 5s disappear. Those 5s disappear. And it turns out that x is equal to positive 1/2. So our final solution is 1/2, negative 1/2. Any questions on any of that? And is there anything else that anybody would like to see? Okay, that's great. Jackie, is there anything else you'd like to see?
Morgan, could you just do one of the word problems?
Absolutely.
Just to put me in the right mode for that. Thanks.
Yeah.
Doesn't matter which one.
I'll go ahead and do the first one. It's as good a one as any.
Okay.
So Shannon's Catering is planning a spread for an open house. She's planning to serve a locally roasted mix of nuts. She would like her nut mixture to be 25% peanuts, but the only sources of mixed nuts come as either 40% peanuts or 10% peanuts. How much of each mixture would she have to combine to produce a 10-kilogram batch of nuts containing 25% peanuts? So we want a 10-kilogram batch of nuts with 25% peanuts. we're being told that we can get one batch of nuts, which we will call X, which can come in as 40% peanuts. The other batch that we can have come up is only 10% peanuts. So then we need to figure out what do we do with this information so that we can figure out a solution to this problem. Well, I know that if I add up my two batches of nuts, they have to weigh 10 kilograms. So X plus Y equals 10. From there, I know that because my final product is going to be 25% peanuts, I can say, well, of those 10 kilograms, 25%, or 0.25, of my 10 kilos will be peanuts. And I get that from 40% of my first mixture and 10% of my second mixture. This pattern holds pretty consistently when you're dealing with percentages. You're going to add your whatever your two items will be your total weight or volume or what have you, dollar amount. Your second equation is always going to be the percentages of your two things will equal a percentage of your final product. That's pretty consistent. Okay. Having set this up, we can now do a bunch of things all at once. This equation I'm immediately going to rewrite as y equals 10 minus x, so that I can use that as a substitution in here for y. So I'm going to do that, and I get 0.4x plus 0.1 times 10 minus x, and that's going to equal 0.25 times 10 is going to be 2.5. I then share this, so 0.4x, 0.1 times 10 is just going to be 1, minus 0.1x equals 2.5. I'll subtract the 1 from both sides. I'll put my x's together. 0.3x equals 1.5. Then we want to get x on its own. So we'll divide by 0.3 on both sides. And when we do that, see if I can squeeze this down here, we get x equals 5. This nice x equals 5 can squeeze back into this original equation. Y will equal 10 minus 5, which means that y is equal to 5, which means we want 5 kilograms of the first batch and 5 kilograms of the second batch to get a 10 kilogram match with 25% peanuts. Okay. Any questions there? Okay. If there are no other questions that you'd like me to go over, I will let you guys go. And I look forward to seeing you on Thursday. Yes, where we'll be writing tests for the last time. While I've got you both here, just a reminder that there is a survey out to review the course. Please fill it in. Please be honest. It helps me get better year over year.